Well, last time I told you that problem of entropy, which was basically the usable energy in any closed system was always getting down. And closed systems basically means that no energy is going or coming from outside of the system, pretty much. Um, well, and this is a fact that's true for all energy forms, although my description was water. Um, and the Earth is not a closed system, by the way. The Earth is getting energy from outside, namely the sun, which means actually the problem of entropy functions a little differently for Earth. Although, well, different forms of energy we use on Earth, basically the plants and the energy they provide, and dead plants which turn to fossil fuels, or dead animals that which turn to fossil fuels, all are in a way have gotten their initial energy mostly from the sun. Although to some extent internal energy of Earth is also there. Well, wind is an energy that could be used, and energy of the sun itself is actually sometimes used. And certainly on Earth, you will see in a minute, there can be plenty of ways of increasing energy use in the Earth without getting in danger of depleting energy of the Earth in foreseeable future, or having any effect on available energy, reasonable effect on availability of the energy in the future. But problem of entropy is still a problem which stands, and at the very end can be important and critical for us. So let's make it also stand as a problem that exists in the universe and in the Earth also. So now, if the limits are critical, basically, especially if we want to preserve Earth in terms of its availability of the resources, we need to create an economy that is sustainable. Sustainable means the availability of the resources should continue. Well, we have two different definitions of sustainability. Actually, there is a third one which is actually more strict and it's almost never used. The strict one is actually keeping all sources of energy, all natural resources, stable, one by one. I mean, all lakes, all forests, all everywhere in the world, all available natural resources should stay there. Their value should stay stable. Strong sustainability is basically achieved, on the other hand, as opposed to stricter strong sustainability or strongest sustainability, when you keep the total value of all natural resources constant. So you can destroy a forest, but you should create another natural resource in its place, or improve its quality, basically. And here the value of natural resources are measured by looking to the monetary value of them, and that monetary value is calculated by basically calculating their relative benefits. How do we can calculate their benefits? We can calculate the actual monetary resources that are extracted from those natural resources, including holiday resorts in which people stay and basically enjoy the view, for example. That could also be direct revenue you got, direct thing you got from that natural resource. And then we can calculate what will be additional costs when the resource is not there. For example, air quality might be worse. In that case, we might have additional health costs. In that case, those health costs are added. I mean, the monthly health costs will be added to the basically cost of the lake. Also, if I can freely enjoy the lake, but in the absence of the lake, for example, in order to do rowing, I need to go to another lake which is far away and pay gas. Or if I go to a sports, center and pay fees, that gas or that fee, or basically for different people, might be included to the price of the lake. Of course, some people can go to the lake. Some people, if 1,000 people are benefiting from the lake, and each of them have different decisions, and all of their additional costs should be added. So, doing this, it is possible to calculate the value of the monetary value of the natural resource and the value it creates every month or every year. And then keeping value of all natural resources constant in total, strong sustainability is achieved. Weak sustainability, to achieve weak sustainability, the total value of the natural resources and non-natural infrastructure, like sports centers, universities, things like that, should remain constant. So if you destroy a natural resource but build a university in its place, and the value university creates every month is same or more than the forest or lake is creating, in that case you are weakly sustainable, but you are not strongly sustainable, basically. So let's continue. Basically, these are the definitions of sustainability. So how to measure whether we are sustainable or not, and basically how to measure the sources of our effects, basically. In order to measure whether we are sustainable or not, a special type of let's say index is created, which is actually taken as a substitute of GDP, which measures national product, the value of everything we produce measured by the prices, has its strengths certainly, but it is in many cases used as the main measurement to understand or to set how successful or how developed a country is, while in order to increase the GDP, if other things, social harmony, or let's say the natural resources are sacrificed, or for example the housework that is done inside the family is neglected, then the actual welfare that is brought by the increase in GDP might be mismeasured. So that's how GPI is created, and it has many other components in addition to environment, but it also has environment. So when you have environmental resources, their value is added to the GDP, even the value which is not monetary normally inside of the GDP. The hotel's revenue is actually in the GDP. But if the going around the lake is free, basically, the loss of value by not having that lake to go around freely, that is not in the GDP, because that was created by the lake freely. People were initially not paying for it, but now, because they are not going to the lake for the same thing, to get the same service, let's say, or same opportunity, now they need to pay money. So that effect is included to GPI. So how can we decompose our impact? Basically, it is decomposed in three components, although two are pretty much can be taken as together. P is population. The more people you have, as long as their consumption level is the same, as long as the for the same level of consumption, same level of waste is created or resources extracted, increase in population, other things constant, will create more pollution. Affluence is actually the effect of every person. So this consumption per capita, if it can go down, basically, even though population is fixed, basically the effect of the total effect of people will still go down, because each person will will basically consume less, and assuming that the effect created by the same consumption level remains the same, that means less pollution or less resource extraction. Note that this can be taken as GDP per capita, and the population times affluence is the GDP total production level. So this is actually total production level, total level of everything being produced, including the consumption goods. We should note that in a capitalist economy, we need, in order to have a healthy economy, continuous growth rate. If you think this might be an overstatement, just think, how would people react, how would you react if an economy is in stagnation? What is stagnation? Stagnation is at the time when GDP is constant. And depression is the time when GDP is going down. So whenever GDP even remains stable, that's taken as an unhealthy situation for the economy. Well, environmentalists are for a long time looking for a low zero growth or negative growth economy, but whether this is possible in the capitalist system is a big question. And if this is not that much possible, then we are falling back to intensity. What is intensity? The resource extraction or waste disposal per unit consumption. So can we decrease the resources that are needed for the production or the waste that are disposed per production, basically? And the main way we can reduce our intensity is falling back to technology, having technology that will develop basically our ability to produce things without use of that many resources or produce that much waste. But another way to do it is actually changing our consumption and consume more the type of goods that even with current production techniques need less resources or produce less waste. For example, if someone thinks that's possibly a product, but that product doesn't have any waste besides the waste humans are producing every time, the extra energy that person needs for thinking, basically. So, potential solution, market mechanism we have discussed. For resources, it can be sometimes useful if the prices of the resources are actually affected by them when you got close to the limit. But in other cases, in many cases, the price mechanism doesn't start to work up to the very point when the resource is very close to depletion. And this idea is actually expressed very early on by the neoclassical economists, actually, and the politicians that were following them, by a special model called tragedy of the commons. It is assumed that you have a pasture, and that pasture, if it is open to use of everyone will make as many animals as possible to use that pasture. But when so many animals use that pasture, the pasture will get depleted. When you could limit number of animals use the pasture, in that case, the pasture would survive. But as an open pasture, the pasture will certainly be depleted because for anyone, just restricting the number of animals they get into the pasture won't change anything, basically. I will talk more on tragedy of commons in the next part.